Hey guys, welcome back to another RASK Maths tutorial. And in this tutorial or video, I'm going to be showing you guys how we can solve the system of simultaneous equations. So at first glance, this looks like a pretty tricky system to solve, right? Because all of the equations and variables are mixed up between the equations. And if you try and solve this using normal methods like substitution or even elimination, it's just not going to work, or it's going to become really complicated. And so yeah, I'm going to show you a trick to solve this, and this trick is actually used in quite a few places, so it's good to know. Essentially, the trick all comes down to combining these equations into a single equation and then completing a square to show that um, each bracket has to be equal to 0. So I'll show you what I mean. First thing to notice here is that each one of these kind of look like they sum to 0. They don't actually, but that's where these extra constants come in. So you might notice something like this. Let's rewrite each equation to become, well, we'll look at the x, and we'll look at, if we were to add everything up, then we'll look at where it's meant to be. And sorry, this z is meant to be an x. So we have an x here and a 4x here. So we could write the first equation as x squared. Sorry, let me do this with the y instead. So we'll do this with the x squared minus 6y, and if we imagine now there's a y squared here, then when we complete this square, we're going to end up with a y minus 3 in the bracket minus a 9. So what I'm going to do is just rewrite this first equation as x squared minus 6y plus 9 minus 9. So notice now when we add in this y squared, this becomes a perfect square. Right now we haven't actually done anything because we just left it as 0. And we'll leave that like that. Now the second equation, we have a 2z, so again, I'm going to try to convert that into a partial perfect square. So we'll write that as 2z plus 1 minus 1, so now if we add a z squared into here, this becomes a perfect square. And we'll leave the minus 7 like so. And finally, let's rewrite the third equation to be in the same kind of form. So we'd get z squared plus 4x, and we do plus 4 minus 4. Again, if we put an x squared there, this becomes a perfect square. And right now it's just a partial perfect square because we haven't added the equations together. And now we've rewritten all the equations in this form. So what you'll notice now is if we just look at the constant terms, they actually all cancel out. And sorry, not all of them, but if we ignore the ones onto this side, so let's just look at the ones over here, because the ones in over here are going to get converted into perfect squares. So you'll see all of these cancel out. We get a minus 9. Yeah, so these 7s cancel out. This is a minus 14 over here, and then we have a plus 14 over there. So they all cancel out. And when we add together all these equations, I'll do this bit of completing the square at the same time. So we'll look at the x's first. We have the x and the 4x plus 4. So when we complete the square on that, sorry, just convert it to a perfect square because that's what we already did, we're going to get a x plus 2 squared, right? Now let's look at the y's. So we have y squared and minus 6y plus 9. So when you turn it into a perfect square, that's just going to become y minus 3 squared. And finally, when you have the z squared and the 2z plus 1, when you combine them by adding them all down, that's just going to turn into a z plus 1 squared. And we've already shown that it's equal to 0. So now what we need to use is the fact that anything squared, I'll just use the letter I to represent anything. I squared is always greater than or equal to 0 because the square number is always greater than or equal to 0. And so you'll see if it's equal to 0, that the only way this can happen is if each one of these terms is equal to 0, right? Because if any of these weren't, then none of these can be negative, so we can't get rid of any of the progress we've made, if that makes sense. So what we can do now is we can split this up into x plus 2 equals 0, y minus 3 equals 0, or we put it as squared and then we could just take the square root, and z plus 1 equals 0. So therefore that gives us our solution as x equals minus 2, y equals 3, and z equals minus 1. Now, we need to make sure we plug these back into the equations to check they work, because otherwise, it's all right doing all of this, but we need to make sure that after doing special manipulation like this, it's always best to just check in the end, because even if you've done completely valid algebra, sometimes you'll get wrong results. So let's use these, just put them in, x squared minus 6y plus 14. That would be 4 minus 18 plus 14, so that works. Y squared plus 2z minus 7, so that would be 9 minus 2 minus 7, which is also 0, and z squared plus 4x plus 7 is 1 minus 8 plus 7, which is also 0. So there we have it. These are our results, and that is an interesting way to solve this system of equations. Thanks for watching, and I'll see you guys in a future tutorial. Bye!